Hi everyone. Today we shall go through the Stack Overflow tag prediction case study. I am trying to solve this case study, and I found the data for this on the Stack under another Kaggle platform. Okay, let's go. Here I am importing all the necessary libraries for the which are required to complete this case study. And let's go. Let's see what is the business problem that we are trying to solve. As we all know, the Stack Overflow is the largest platform where all the developers in the world try to build careers, improve their knowledge by asking questions and answering them. And it is very important for the Stack Overflow to suggest the right kind of questions to the right users. And they do this by keeping tags to each question. Each question might belongs to different types of areas, like a question might belong to Linux operating system and also a Python, which means that there is a Python script which needs to be deployed on a Linux operating system on a server for to use it in a web application like that. And the problem statement is that, and we can here it is the source for the dataset on the Kaggle, and here a bunch of useful resources which is the research work by previous researchers on this dataset. Now coming to the real world business objective are the constraints that we are having while solving which we should keep in mind while solving this problem is that we have to predict as many tags as possible with high precision and recall, because if wrong tags are predicted for a question, this might affect the customer experience on the platform. And there is no strict latency requirement. That is there is no need to compute there is no need to predict the results in milliseconds like that. So we have to predict as many tags as possible with high precision and recall, and we should avoid wrong tags, and there is no latency requirement. And we have to map this to a machine learning problem. Let's see the data. Let's take a look at the data. Here in the dataset we are having two CSV files which contain and the CSV train.csv and test.csv. Train.csv contain four columns ID, title, body and tags. And here we can see that the size of that this files, which is 6 GB and 2 GB. By seeing the size itself, we can we have to be prepared that we need some better logics while dealing with these files using pandas library. So what I have done is that I have created a SQL database, and from that database I'm doing all the analysis. The reason for that is that one thing is that SQLite is more stable, and it might be a bit faster on some operations. And I also wanted to try out the SQL database. Like if there is a database, there is data in the database which is not as a usual CSV file. So then how to deal with such data sets. So I'm creating a database, and I'm doing all analysis from that database itself. Now here we can see that there are almost 60 lakh questions in this data set, and the four columns that I said which are present in the trainer.csv are ID, title, body and tags. Title is the name of the title put by the questioner, and body contains the content of the question, and tags, this is what we are we will be predicting. As discussed earlier, there is no single tag for each question. There will be multiple tags for each question, because a question could belong to any different categories. Here is an example data point, like this is the title this question of the question which is about the C++, I guess. And here in the body we can see that there are a lot of special characters, and there will be a lot of HTML tags also. So we need to preprocess this data and remove all these special characters and HTML content before proceeding for predictions. Now mapping the real world problem to machine learning problem. Since there are many tags that we need to assign for each problem, this is a multi-label classification problem, which means that there will be multiple targets for each there will be multiple targets for each question. And let's decide what kind of performance metrics we will need to evaluate the model's performance on this data set. Since we want to predict the right kind of labels, as many as possible with high precision and recall, we need a metric which will take into account both the precision and recall. And one such metric is F1 score. And the two variations of F1 score is micro F1 score and macro F1 score. We will be using both of these. And the difference between these two is that micro F1 score will take into account the class imbalance if there is a class imbalance, and macro F1 score, it doesn't take the class imbalance into account. There is also another metric called Hamming loss. The Hamming loss is the fraction of the labels that are incorrectly predicted. So we will be using both micro F1 score and macro F1 score. And let's analyze the data. As I said earlier, I have created in this code block, I'm reading the CSV file in chunks, and then creating a database, SQLite database called train.db, and I have created a table called data with which contains 4 columns: ID, title, body, and tag. Now after running this cell, I will be getting after running this cell, train.database has been created. Then counting the number of let's count the number of rows present in the database. So as we have seen above, there are almost 60 lakh questions or rows present in this database. Here we can also see I have also computed the time to run this query. This is the query that I am using to query the database using SQL pandas connector. Now here I am checking for the duplicates. I am checking for the duplicates. I will be getting a database data frame from this query, and I have also created a new column called count, which will count the number of times the same row has appeared. So the same row has appeared. Using this column, I can see that that is almost 30% of the questions are repeated, which means that the same question is being asked by the different users. And the main purpose of this case study is that to point all these all of these users to a single answer, to get all those users at one place where they would all be benefited. That is the main task. Now I'm also creating another column known as tag count. Means there will be multiple tags for each question, so I'm just counting the number of tags present for each question to visualize to see how many tags are present for each question. And I'm also here, what I'm doing is that since 30% of the questions are duplicates, I'm removing all the duplicates and I'm creating another new database called train.node.db. This only contains title, body, and tags. Then let's go for the analysis of the tags. The tags are present. The tags in each row are just separated by a space. So I'm using count vectorizer to encode all these tags, and I'm using this tokenizer to split each tag. And I'm just doing fit transform on tag data of tags. As we can see that there are a number of data points after removing the duplicates is 42 lakhs, and there are a number of unique tags is 42,000 unique tags are present in the whole data set. Here we can see a few of the tags like ASP.NET, Bash profile, CS file, .doc, etc. etc. Number of tags, number of times a tag has appeared. A tag might have appeared many number of times, And here I just written a code to count the number of times a tag has appeared, and I created a small data frame here. And here what I am doing is that this is there are 42,000 tags. I'm just plotting the tags on x-axis and the number of times a tag has appeared. Like it is a distribution of the tags. Here we can see that there are few tags which have appeared more than 30,000 3 lakh times. And what I am doing is that since there are only few tags, I am let's consider only top 10,000, first 10,000 tags, and we get the distribution as follows. Top 1000, for top 1000 we get the distribution as follows. As we can observe here, the curve is getting more curvier, like in this region, since we are only taking less number of tags to analyze. As if we take only the first 500 tags, we can see that there are few which has appeared more than 33 lakhs, 22 lakhs, like that. And here we can see that there are 153 tags are used more than 10,000 times, and 14 tags are used more than 1 lakh times. We will also further see in down the code. We will see that the tag which has repeated most number of times. Let's visualize how many tags are present on average for each question. Here I have plotted this graph. Here you can see that there are almost 5 tags for each question. There are maximum of 5 tags per question. So maximum number of tags per question is 5. Here you can see the minimum number is 1. Average is on an average every question is having 2 or 3 tags. What I have done is, next, to find the most frequent tags, to get an overview, I have plotted a word cloud of all these tags, just to get an idea of which tags has appeared most number of times. Let me zoom this. In this figure, as we can see that the language PHP, Java and C# has appeared the most number of times. We could also find Python somewhere here. Yeah, Python, which was not famous at that time. Maybe now it would be having the top place. Okay, now we can also plot here I have plotted a bar chart to see the tags versus number count, and here we can see that C#, Java and PHP are in the top 3 places. These are the top 20 tags, and Python is Python is here in the top 10, I guess. Now this is the data analysis part I have done. Now let's move on to the cleaning and pre-processing. As I have said earlier, the content of the question, it contains code blocks, HTML tags and special characters. We have to remove all of those special characters, and since there are 42 lakhs like 4 million data points, due to memory constraints, we will be dealing with 1 million with 1 million data points. And what we do again is that separate out the code snippets from the body, remove special characters from question. We should be careful not to remove the C, the word C. It is not a stop word, which is a tag for all the questions that belong to the C language. And we should remove HTML tags, convert all these characters into small lowercase letters, and use snowball. I have also used snowball stemmer to remove the words that are more similar, like moving, like that. And I have written a bunch of functions here, like each has its own purpose. This one is called strip HTML, which will strip all the HTML content, and this is just to create the database connection. So here what I am doing is that I am creating a new database called questions pre-processed, which I will add to this database after doing all these steps on on the content of the every question. So all these 7 steps will be performed on the content of the each question, and then that pre-processed content will be added to this database called questions pre-processed. Actually, it's not database; it is a table. I have created questions processed table. Now here we can see that I am performing all the 7 steps that I have mentioned earlier. Here I am separating out the code, and I am removing all the special characters. I am encoding. So I'm using that strip HTML function that I have written about to remove the HTML content. And I'm after pre-processing, I'm just joining all of the words using here I am performing stemming. Yeah, then I'm joining all of the words. So I have pre-processed all the questions here. I am closing the connections of the database. Here we can take a look at the first few of the processed questions. Here we can see that we can see the processed questions. Yeah, there is no code, there are no HTML tags. Stemming is performed. All the special characters are removed. Yes. Yeah. No, I don't see any special characters here. And now I have to write all this to a database, to this processed DB database, which contains this questions processed table. So I am creating a data frame here. I have created. Yeah, this is our final database. Here we are having the questions which we need to encode. We need to encode this to convert this to numerical format, and we also need to encode the tags also, since because we are having so many there are having 4 to 5 tags for each question. And number of data points samples I have taken for doing modeling is 1 million. Now let's convert encode the tags. I'm using count vectorizer, and I am setting binary is equals to true, so that I will get the binary vector, like I will get 0 or 1 in that format. And I am fitting and doing fit transpose on the pre-processed data of tags. Here I am encoding the tags. Have written as we have seen earlier, there are 42,000 tags. There might be some tags which might have occurred only at some which might have be present only in some questions, and and those tags it is better to remove those tags, because they might they are like outliers, not outliers, there are only rare occurring things. So what I have done is I have written 2 functions here. One function, this will do is it will choose the number of tags. Here n is the number of tags that I am telling it to choose, so it will choose the number of tags. And this second function, what it will do is that the number of tags that we have chosen from the first function is covering how many questions. That will be done by this second function. As we can see that here I am considering here I am plotting this number of tags on the x-axis and the number of questions covered. We could see that at 5,500 or 6,000, almost 99% of the questions are being covered, and all the tags which are present in this region, they are only occurring in very few questions. In 1 million, they might be occurring in some 100 or 1000 or 10,000, which is very quite less. Here I have also computed the percentage. I have counted the number of questions which are having rare tags. Like here you can see, out of 1 million, there are only 9,599 tags that are not covered. And so this 5,500 is 15% of all the tags, and the number of tags, that 15% tags of all the 42,000 tags is 35,422. This is covering almost 99% of the questions. Now here we are doing splitting the data, like 80% for training and 20% for testing. We are also having a test.csv file, but to make things simpler, I am just splitting this the train.csv file that I have been processing into train and test. But in practice, we have to process the test.csv file and do our testing on that data set, because it is a good idea, because it is always better to use more data for training. So here I am doing the splitting. As you can see that how many there like 0.8 million for training and 0.2 million for testing. And now since our data is text data, we have to featureize the questions also. So I'm using a DF-IDF vectorizer. Minimum DF is this, and maximum features I'm using is 200,000 maximum features I'm setting, and I'm using L2 norm. This is the tokenizer I'm using. That means it has to, all the words are separated by space in the question. So I'm initializing the DF-IDF vectorizer instance. Then I'm fitting that vectorizer object on the questions column of this training data. Then transform both the test and train. That means we are only fitting on the train data, but transform both on train and test data. We do this because we should not expose the training data to our model, test data for our model. Next, after featurizing the data, I'm applying logistic regression with one versus test classifier. Here I am initializing the one versus test classifier. I'm from a sklearn library. I have imported this class, and this is the object of the class, and fit on the train and test data which has been featurized, and I'm also making predictions on the test data. Here we can see that there is the accuracy, macro F1 score, micro F1 score, Hamming loss, and the precision report, which I'm getting from the sklearn inbuilt functionality. So here we can see that there is only 8% accuracy I'm getting, and my macro F1 score is 0.9, and micro F1 score is 0.3. These should be near 1, which should indicate that our model is performing well. So we might have to consider more data, since we are only taking only 1 million data points, but in the dataset we are having 4 million data points, and we should also utilize the test.csv file also. Now let's do modeling even with the less data, 0.5 million data. But this time what we will do is that we will add more weight to the title and 500 tags only, and we will reduce the tags, and we will add more weight to the title. So I'm doing all the pre-processing steps again. Then this is the same thing which I have done earlier. Closing the connections, pre-processing. I have also added weight here, weight to the more weightage to the question to the title. These are the pre-processed questions. Now we can see that the pre-processed this is our final data. I'm again doing the count vectorizer and the tags, featurizing the data. Now we can see that with only by taking 5500 tags we were covering 99% of the questions, but with just only 500 tags we are still covering 90% of the points. So this would greatly reduce our training time, and let's see what would be our results on this. Here number of data points. Okay, featurizing the data again with TF-IDF vectorizer. Maximum features is 2 lakhs using that same tokenizer, and again applying the one versus rest classifier. The only difference between the previous model and this model is that this model is having very few tags, but we are adding more weightage to the title. We are adding more weight to the title, and see how this would affect the model's performance. As we can see that here the accuracy has increased to 23% compared to 8%, and the Hamming loss and micro F1 score is 0.7 and macro F1 score is 0.5, which were only 0.03 and 0.3 I guess, which were very low previously. So by adding more weightage to the title we are definitely improving the performance. So and we are only considering we are only considering 500 tags for this. So if we train this data for more on the data points that we have left out due to memory limitations, the model's performance would still increase. Next, here I am just packaging the model to a pickle file here. In our next video we will see how to deploy this model, how to create an API using Flask or Fast API, then deploy this API to a VM, so that one can make predictions from this model. Like one can utilize that API to make to integrate into their web application. So we will do that in our next video. Thank you.